We are now passing the milestone in which we expect the solar arrays to be deployed. Again, this is the expected milestone. It's dark out there. Again, no sunlight. Now you're looking at a view of inside the Mission Directors Center. That front row there, staffed by the team from the Goddard Space Flight Center as they look anxiously at their monitors. The solar arrays are expected to take a few minutes to deploy. If it holds to the milestone, so we just got word that they have confirmation the solar array deploy has begun. Again, solar array deploy has begun for the spacecraft. It's a 3-panel array. It's a critical milestone. And what goes hand in hand with that, Mick, is for the GNC, the Guidance, Navigation, and Control, to get that spacecraft and that solar array sun pointing. Can't do it yet because there is no sun in its current state. But we got a good ride into space. We will continue to monitor the nets here and the PACE spacecraft team. But in the meantime, we're going to send it back to Jasmine and Laura.
Thank you so much, Daryl and Mick. A beautiful launch followed by a smooth ride into space so far for PACE. Laura, what do you think?
It was absolutely stunning, and we are so relieved. Everybody in the PACE team has been cheering. All of our NASA colleagues have been cheering, as have all of you been cheering. So it is a great dawn for PACE and ocean and atmospheric sciences.
It really is. That was a great way to put it, Laura. So if you are just joining us, you are watching NASA's official coverage of the PACE launch. That's the Plankton Aerosol Cloud Ocean Ecosystem. It lifted off about 16 minutes ago aboard a SpaceX Falcon 9 rocket from right here on Florida's Space Coast. So now PACE is on its way to orbit 420 miles above Earth, where it will collect data on both particles in the ocean as well as the air. Let's take a closer look at how those are connected.
Between September 2019 and March 2020, wildfires killed billions of animals and decimated more than 200,000 square kilometers of Australian forest. Some thousands of kilometers away, in the Southern Ocean, massive algae blooms covered a surface larger than the area of Australia itself. Just how are these wildfires and ocean blooms connected? To untangle that, we look to the carbon cycle. The carbon cycle is the flow of carbon between reservoirs in the atmosphere, plants and animals, land and ocean. If we look to the ocean reservoir, carbon dioxide is also absorbed by phytoplankton, microscopic organisms that convert carbon dioxide, water, and sunlight into carbohydrates like sugar and oxygen through photosynthesis. Carbon dioxide released into the atmosphere eventually becomes available for aquatic photosynthesis. But photosynthesis also requires nutrients such as nitrogen, phosphorus, and iron. Without the right proportions of these nutrients, photosynthesis doesn't happen, which can be seen in the iron-limited parts of the ocean, such as far offshore of Australia. Atmospheric aerosols released by fires, however, contain carbon as well as other nutrients essential for plant growth, like iron. When these aerosols are deposited on the ocean's surface, these nutrients become available for photosynthesis. This iron from the Australian wildfires is now thought to have stimulated the massive Southern Ocean phytoplankton blooms, blooms of such magnitude that they converted an almost equivalent volume of carbon dioxide released by the fires into carbohydrates and cellular material.
With an instrument like OCI, where you're measuring this full spectrum of color, all the colors of the rainbow you can imagine, we can start teasing apart the species and the different functional groups and different communities that exist.
The data from PACE will help define those communities, allowing for clearer connections within the reservoirs of the carbon cycle. These fires emitted a huge amount of carbon and other aerosols into the atmosphere. Those aerosols contained essential nutrients that are thought to have stimulated the rapid growth of phytoplankton in the Southern Ocean. And these kinds of connections can have big impacts.
It's really important to know where the carbon is going and where your food source is going. This is important for not just climate studies, but food security.
With data from PACE, we'll get a clearer picture of carbon as it links land use and fires, atmospheric aerosols and marine communities, and ultimately improves the data that we put into climate models.
NASA scientists are hard at work using data like what they'll get from PACE to better understand climate change. Megan Cruz is standing by with one of NASA's experts on climate science right now. Megan?
Hi, this is Kate Calvin. She's NASA's chief scientist and also the senior climate advisor for the agency. What a beautiful launch we just saw.
It was beautiful, and it's so exciting to see this mission go and start to send us data soon.